All right. So here we have two functions and the question asks us to find the derivative. So f prime of x. So for the first one, how do you find the derivative? What do you guys think? So it looks like composition of functions, right? You have your outer function, which is cosine, and then you have your inner function, which is this guy right here. So something like this, if you want to differentiate, you have to use the chain rule. Whereas this one, b, you have a function here and a function here. So two functions that are multiplying together. So you would use the product rule, and within that you might have to use chain rule. But the main rule that you will be applying is product rule. Marvin, let me know if that makes sense. You see the difference?
Yeah, so pretty much like, wait, no, not really.
Okay, so let's differentiate the first one. So using the chain rule, first you differentiate the outer function, right? So outer function is cosine. What's the derivative of cosine?
Negative sign.
Right, so we keep the inside, so we have negative sine of the same thing inside. Now times the derivative of the inside, which is only this right here. So you differentiate that term by term. So derivative of x, that's 1. And what's the derivative of 1 over x? We can write that as a power, right? Go ahead.
Negative x squared, negative x to the negative 2.
Right, so or we can say just like that, right?
Right.
So, and you can leave it right there. So for the final, you don't have to simplify your answer. The chain rule is applied, and we took the derivative of the inner function by using power rule. So this would be your final answer for A. Let me know if anyone has question or if you have any questions on this. Now, what about the second one? So second one, you have two functions, right? So you can call ln of 2x as f, and then 3 square root of x minus 1 over x squared, call it g. Now there you have to use product rule, and within the product rule, you might end up using chain rule, power rule, and other rules. So if I set up, no, I actually want to change the notation because I already called that f. Let's call this h. So your derivative of f of x is going to be, you differentiate the first, you keep the second, and then you keep the second, you differentiate. Sorry, you keep the first, differentiate the second one. So let's go ahead and differentiate h. So h is ln of 2x. What's the derivative of ln of any function is 1 over that function times the derivative of the inside. So derivative of 2x is simply 2. And then you keep the second, that's 3 square root of x minus 1 over x squared. Now plus, now we keep h, which is ln of 2x, and now we differentiate this function right here. And that's going to be just a bunch of power rules. So we differentiate 3 square root of x. That's going to be 3 over 2 square root of x. And then 1 over x squared, you can make that into a negative 2 power. So that will be positive 2 over x to the 3. And again, you can leave it right there, or you can just clear out some of the factors. For example, this one, I can cancel out those 2's. So my final answer will be 1 over x times 3 square root of x minus 1 over x squared. And the second one, I'll just leave it as it is. There's nothing really to simplify. ln of 2x times 3 square root of 2 square root of x plus 2 over x cubed. So that would be your derivative for the second problem. So this was product rule and power rule and chain rule. So it was 3 different rules being applied. So let me know if you guys have any questions. Oh, sorry, Cynthia, can you tell me that again?
Thank you. For the second example, degree of the top is less than degree of the bottom and it equals 0, that means,
Right.
oh, you did write it. It says y, so y equals 0 is a horizontal asymptote.
Right, so this is the horizontal asymptote.
Is it possible for you to draw that on the graph? Because I'm just a little confused.
Yeah, I think we did one. So if you look at the sample, this is sample 1. I think it's the last question.
Thank you.
The sketching, this one right here. If you take the limit of this function to find the asymptote, so I'm just gonna write on it. So this is the limit as x approaches plus or minus infinity of x squared over x squared minus 4. Now, since the degrees are equal, this limit is their leading coefficient, which is 1. That's why y equals 1 is your horizontal asymptote. And that's what I have it here on this sketch. This line right here, which is our horizontal asymptote. Now, if I had it other way around, let's say, so if I want to make it 0, right, I would just put up maybe something like that, a constant over that, where the degree on the bottom is greater than the top, because you can think this is x to the 0 power. So in that case, your limit goes to 0 as you approach plus or minus infinity. So the horizontal asymptote would be y equals 0. So in that case, if I were to graph it, it will shift down 1 unit, this graph. I
Okay,
don't know
thank you.
if that makes sense.
Yes,
yeah?
it makes perfect sense. Thank you so much.
All right. Any other questions, guys? Okay, so let's integrate this. Now, it's a definite integral, right? So I show you guys 2 different ways to do it. You can change the limit of integration based on your u substitution, or don't change it at the end, come back to the x variable and you plug in 1 and e. So what are you going to select u to be? Because this is a u substitution, right? We can't just use power rule. So I'm going to let u to be ln of x. So the reason I do that, because I see I have a 1 over x right here, right? So we're going to let u to be ln of x. So that means its derivative is 1 over x dx. And that's exactly what we have in the integral. I have u that's right here. And then this is my 1 over x dx. That's my du. So my integral in u variable, it's going to be the integral of u times du. Exact substitution, nothing to change. Now, do you just want me to change the limit of integration or come back to my x variable?
I come back to it.
Come back to it? Okay, so let's just continue. So you're going to treat it as an indefinite integral. So what's the integral of u respect to u? We use the power rule, right? So this is u squared over 2. And you could put plus c, but I'm going to ignore that for now because I'm coming back to my x variable. Now here, once you finish integrating, plug in what u is. So u is ln of x. This is ln of x squared. So 1/2 ln of x squared. And now we can put the limit of integration, which is 1 to e. So now we plug in the upper limit first. This is 1/2 ln of e squared minus the lower limit, 1/2 ln of 1 squared. Now you shouldn't leave it here because we know what ln of e and ln of 1 is. What's ln of e? Do you guys remember what ln of e is? 1, good. So this is 1/2 times 1 squared is 1 minus, and what's ln of 1?
0.
0, good. So this is 0. So this will disappear. So all of this just simplifies to 1/2. So this integral evaluates to 1/2. So these are the steps we took. So any other questions or any questions on this problem?
Professor, it's Catherine. I was
Hi,
wondering what
Catherine.
happened to du. I'm sorry.
Du.
Yeah.
Oh, so are you looking right here?
Yes.
So once you change your integral in terms of a different variable, which is u, we did. Now the integral symbol and this symbol, they're they're kind of like glued together. You cannot separate them. It's a notation that tells you, okay, integrate, meaning find the antiderivative. And that's what we did right here. Now, once you do that, you drop this and you drop that together.
Oh, okay.
Yeah, so they come together, they live together, they're like best friends.
Okay.
Yeah.
I have one more question.
Sure.
So I know you chose u to be ln of x, but how do we determine what is the correct choice for u in u
It
substitution?
depends on the question. So whatever you select u to be, the derivative or some form of its derivative has to be up here in the integral. So let's say you didn't pick u to be ln of x. Let's say you pick u to be, what do you want to pick? Let's say you didn't see ln of x is the right u.
I saw 1 over x.
Okay, well, so let's say
Yeah.
you chose that. So if I pick that to be u, then what is the derivative of that? So this is same as x to the -1, right? So du, it's going to be negative x to the -2 or -1 over x squared dx. Well, I don't seem to see that in my integration, right? So I'm able to make substitution for this. I'm calling that to be u, but then there's a ln factor there that doesn't get substitute in for any variable. So you're stuck. It doesn't progress. Then you switch. Okay, so that's not a good choice for you. We're going to switch around. We'll say, okay, what if I choose u to be ln and it works? Do you want to try another problem?
Yes, I understand, but yes, can we try another u substitution problem?
Yeah, so let's do this one. So why don't you guys try this problem? So give me a second, let me think of something. So let's do 5 over x ln of x dx. Yeah, this should work. Okay, so try this one. I'll give you guys a minute and then we'll talk about it together. Okay, so let's start. So someone tell me, what's your selection for u?
I have 1 over u.
What is it?
U equals ln of x.
ln of x, okay. Now, does anyone have a different selection for you? Or do we all agree with this? Okay, well, let's go with it, right? So if u is ln of x, right? So I'm selecting this to be u, just that. Then what is du?
I put du as 1 over u.
Well, du wouldn't be 1 over u, right? So du
Oh.
is just the derivative of that.
Mhm.
So it's the derivative of ln of x, which is 1 over x, right?
Mhm.
Dx. So that is your du. So this right here, it's replacing with u, and then you can think of this as 1 over x. So 1 over x is going to replace with that du. Now you see how everything is taken care of? So the only thing it's not taking care of is 5, but 5 is a constant, so I can pull that outside of my integration. So this is same as writing 5 times the integral 1 over x times 1 over ln of x. I'm writing it this way so that you can clearly see what we're substituting in. So this and this together, they're going to be replaced with du. And ln of x right here, that is going to be our u. So this is what the integral will become. So we'll have 5 times the integral of 1 over u du. Let me know if that makes sense.
Yeah.
Yeah. And now, do we know how to integrate 1 over u? What's the integral of ln of, oh, sorry, 1 over u? I think I just gave away the answer, right? So you guys should get 5 times ln of u. plus c, right? Because integral of 1 over anything, right? 1 over x, 1 over u, that's just ln of that function.
Mhm.
So we finish integrating. Now we just sub in what u is, because you always want to go back to your original variable. So here I'm going to sub this in here. So my final answer, it's going to be 5 times ln of u. Well, that's ln of x. Now I'm going to put absolute value to be safe. So this is ln of absolute value of u. This is ln of x plus c. So that will be your final answer. So, Catherine, let me know if you have any questions with the selection of u, or anyone has any question, let me know.
No, that made perfect sense, Professor. Thank you.
Okay, sure. Does anyone have any questions on this problem or any other questions?
I got a question on problem B. Well, problem 2, 5B.
So the same
You-
final, the
Yeah.
sample. Question 2b,
You want
You just passed it.
I passed it. This is 2, this is b. Oh, okay. Huh. All right, so here we're integrating a trig function. So Roy, what's your question?
so basically everything about the question. I just want you to like go over the
Work it out.
steps. What should I look at when
Okay,
I'm for solving that problem?
so if you see something like this, try to think of an identity or factoring. So when I saw this question, I was like, okay, identity, factor. I see I have cosine 3x, cosine 3x. So I can pull it out, right? So it's like having x squared and x, you pull out a common factor. So first I'm going to do that. So I have the integral of cosine 3x, and then factor, you'll have cosine squared of 3x minus 1. So let me know if that makes sense.
Yeah.
Yeah. Now here you want to think of identity because you have cosine squared, because we can relate that with our Pythagorean's identity. Sine squared x plus cosine squared x equals what?
1.
1, right? That's the identity we're referring to. So your argument is 3x. So I'm just going to rewrite the identity for 3x. So you're replacing all of these x with 3x. The identity still carries over. So you can say sine squared of 3x plus cosine squared of 3x is 1. So I want to switch things around and I want to replace this with that identity. So I can do that by subtracting 1 from both sides and subtracting sine squared 3x from both sides. So you'll get cosine squared of 3x minus 1 equal negative sine squared of 3x. And that's what I'm going to substitute right in here. So let me know if you're okay with this so far.
Yeah.
Yeah. So our integral now becomes the integral of cosine 3x, and cosine squared 3x minus 1, I replace it with the negative sine squared of 3x. And the negative is just the negative 1, so you can push it outside the integral. So I'm going to do that. So this is just times like that. And here you can use a u substitution. So everything is rewritten so that you can use u substitution. Now you have to be clever where you're going to choose your u to be. What do you guys think?
Sine squared of 3x.
Almost. So I wouldn't pick the
Sine 3x.
square, just sine 3x. Yeah. So check this out. Why? So if I pick sine square of 3x to be my u, then my derivative is, you have to use the chain rule, right? So you would have to bring down the power, keep the inside, and then take the derivative of the inside. That's cosine 3x times 3. You see how we don't have all of these in the integration. That's why choosing dropping that will be a good selection for you. So I'm going to not choose that. I'm just going to pick sine 3x to be my u. Because once I do that, all I have to rewrite the integral will be u squared, and hopefully du is somewhere there. So let me know if anyone has any question why my selection for u is sine 3x. Okay, so carrying on. So derivative of sine 3x, that's cosine 3x times 3 dx. And that's exactly, well, almost right. I have it here. All I need to do is take care of that 3 by dividing it through. So my 1/3 du would replace cosine 3x dx. So that's why this is a good selection of u. So u is this, and du is going to be replaced with that. Any questions so far?
No.
Okay, so let's rewrite the integral. So we have negative the integral of, so cosine 3x dx, that's replaced with 1/3 du. So I'll put the 1/3 outside. And then sine squared, that's going to be u squared du. So that's how the integral looks like. And this you can integrate by using the power rule of integration. So let me know if anyone has any questions up to this point. Okay, now let's integrate, right? We know how to integrate u squared. You add 1 to the power, right? And same power goes on the bottom. This is 1/3 times u to the 3 over 3 plus c, because it's indefinite, I think, right? Yeah, it's indefinite. And now finally plug in what u was. U was sine 3x. So this is negative 1/9 sine 3x to the 3rd power plus c. So that will be the final answer.
Okay.
You got it?
Yep.
Okay, good. Okay, well, any questions on this problem? Okay, well, any other questions? So this one, you have to realize that it's one of the trig function. So let's recall some of the derivatives. So if you take the derivative of sine inverse, do you guys remember what do you get?
1. Oh, basically that over there is like 1 over radical 1 minus u squared times the derivative of u, or in this case just x squared.
Right, which is just 1. Good. So, and that's exactly what we have here. Now you're integrating that expression, which was your derivative. So that means it will take you back to sine inverse. So that's why I said there isn't much work to do for this problem, other than knowing that it's the inverse, one of the inverse trig functions. So this is sine inverse of x, and of course plus c. Now another one that you should also know is the derivative of cosine inverse and the derivative of tangent inverse of x. So these are very common. That's why I would strongly recommend you to know them. So the only difference between sine inverse and cosine inverse and their derivative is what? Who remembers?
The negative.
Yeah, right? You just put a negative here. And of course, it's 1 minus x squared. And what about tangent inverse? What's the derivative of that?
1 over 1 minus x squared. No,
Almost.
plus.
Plus. This one gets a plus. So these I would remember them if I were you, because they're just very common. And the other 3, they're those reciprocals. You can just skim through them and hopefully you'll remember them. So now, for instance, if I were to give you a question, let's make a C star. What will be the integral of 1 over 1 plus x squared dx? What do you think?
Tan inverse of x plus c.
Yeah. So really just knowing the derivative helps you to think backwards. And we can play around with it, bring in a U substitution. So perhaps we can do something like this. So why don't you guys try to solve this? I'll give you a minute. All right, so any suggestion on how to approach this integral? What do you guys think?
Take out the constant.
Good start. Yes, let's pull the 2 outside, right? So this is 2 integral of 1 over 1 plus x to the 4th dx. All right, what's next? Now this is actually one of the challenging integrals, so I do want to tell you that. Oh, I'll give you a hint, okay? So what if we want to, let's say, select u to be x squared? So let me know if you can work it out with that hint.
You mean x to the 4th?
No, I meant x squared.
Oh, okay.
Yeah. Do you guys see where we're going with this or not yet?
Is it because when you take the derivative of x squared, it gives you back what's in like the integration, like 1?
Oh,
Right.
good point. I'm sorry. I need to give you one more information. Sorry. Oh boy. There we go. Sorry, I missed that. Now you should be able to do it. Now it's good. Sorry, I made a mistake. When I made the question, I didn't think properly. But now you should be able to work this out with the substitution u equals x squared. Let me know if you guys see it. Now here's another hint. So laws of exponents, okay? So we have 2, the integral of x over 1 plus x squared. Let me know if you see it. Okay, well, so I'm selecting u to be just this, okay? Just that little piece to be u, because I know it looks like tangent inverse. Somehow you should see it. Ariana, you see it.
Yeah. I
You see it,
now.
right? Yeah, good. So you have to sometime do that. Like you play around with it, you tweak a little, and then all of a sudden it works. So this one, if you just rewrite x to the 4th as x squared, it works. So based on that observation, I'm selecting u to be x squared. That means my du is going to be 2x dx. And that's exactly what I have in the integral. So you know what I'm going to do? I'm going to push this back inside so you can make the direct substitution. So to follow on with me, so 2x dx is actually your du. And on the bottom, you have 1 plus u squared. Do you guys see that that's tangent inverse?
Yeah.
Okay, so then this is tangent inverse, like we said, tangent inverse of u, not x, tangent inverse of u, plus c, of course, because it's indefinite. And now finally plug in what u is x squared. So your final answer is tangent inverse of x squared plus c. So that's another type of integral, which appears to be one of the trig inverse, but you have to play around with it with a little bit of u substitution. So let me know if this makes sense. Okay. Any questions? All right, so any other questions, guys? Anything you guys want to see done? We still have a little bit more time.
I want to see the L'Hopital's rule, but with
Okay, so for this one, what do you guys think? Which indeterminate form do we get? So if we try to approach infinity, right? As x approaches infinity, this one goes to where? Let's keep on growing, right?
Isn't it infinity minus infinity?
Yeah, so it looks like we get that, which is an indeterminate difference. So you want to convert that into a fraction. So the way we're going to do it is by rewriting this function. Now, because there is a negative sign in between logarithms, you can pull them together, right? So here we're going to apply the law. If you have ln of a minus ln of b, that's ln of a over b. So using that rule, I'm going to convert this into the limit as x approaches infinity of ln of 2x over x plus 1. Now the limit is looking for x, so I can push the ln outside because I can do that. Ln is continuous. So this is the limit. This is ln of the limit as x approaches infinity of 2x over x plus 1. So now you're trying to evaluate this limit. What is that limit?
infinity over infinity.
So you can, yeah, you can say that. Or you can use the technique we studied in chapter 2 to find the limit. So you can do this problem in actually 2 different ways. So I think this was one of the questions Cynthia asked earlier about horizontal asymptote. When you're approaching infinity, and if you have the same degrees, top and bottom, what's the limit?
0. 0.
Well, in this case, it wouldn't be 2. Sorry, the answer is 2. Sorry, I did give you the answer.
Oh, the coefficient.
It's the coefficient, right?
Oh,
Yeah, I'm sorry. I saw the answer before I even worked it out. Yeah, so sometimes it'll happen to you too. So, but if you didn't see that, you can still use L'Hopital's rule. This limit is just 2 over 1, which is just ln of 2. Now say you didn't see that, right? You want to use L'Hopital's rule because it's fun to use. So we get infinity over infinity. Well, if you try to approach this function as x goes to infinity. So apply L'Hopital's rule. So you will have the limit as x approaches infinity of, we differentiate the top and we differentiate the bottom. So if I take the derivative of 2x, I get 2. And if I take the derivative of x plus 1, I get 1. And the limit of a constant, it's always that constant. So this is 2, but wait, I forgot the ln. I forgot my ln outside. So this limit is ln of 2. So you get the same answer, but one way is easier than the other. But to use the L'Hopital's rule, you have to make sure that you get infinity over infinity or 0 over 0, or else you can't really use it. You have to go by what we did earlier in the course. All right, so any questions on this problem? Okay, Ariana, let me know if this makes sense.
yeah.
Okay, well, any other questions from anyone?
Problem 10 of that same test.
10. So here's 10. I worked that out. Did you look at the answers?
See.
So I worked this one out. It's a very long problem. So I would recommend you to look at the answers. This one is similar to the one we did in class, but it has one extra information, which is how much the sites will cost you. So I'm just gonna run through my own solution, but let me know if you have any questions. So you're constructing this cylindrical can made out of two different materials. The sides will cost you $1 per square foot, and the top and the bottom will cost you $2 per square foot. So you want to find the dimension of the can that will minimize the cost. So you want to work with the cost function and take the derivative of that, find the critical number. So the way you're going to use this formula is volume of a cylinder. Now, often on the final, if you have such a question, they'll give you the formula. I believe they do. Volume of a cylinder is often given to you, and volume of a cone is also often given to you on the problem. So you don't have to memorize this formula. So we know we have 1 cubic feet. So volume is 1 equals pi r square h. So that's what I got right here. And then I isolate this variable h so that I have everything in terms of just one variable r. That's what I did here. Now, if you open this can, so let's say you cut through it right at the center and you open it up. So it will look something like this, a rectangle, which means this side is h, but this side right here is the side that will be the circles, the top and the bottom. So that will be the circumference of the circle, which is 2 pi r. So when I'm finding the cost function, which is c, I'm looking at how much it will cost for the side, which is a rectangle. So you have 2 pi r times the height, length times width, and this is the price, $1. And the top and bottom, they're circles. So the area of a circle is pi r squared, but you have two of them, the top and the bottom. That's why I have 2 pi r squared. And this is the cost, $2. So this equation right here is your cost function. And then once you have everything in one variable, you start differentiating. And that's what I did here. So run through it again on your own, but pretty much these are the work that you have to do for these kind of questions.
You don't have to take the second derivative in this case to find out the max, because that would be complicated, right?
So the second derivative will be for this function, which is not complicated really.
Oh, sorry. I didn't.
Yeah. So I did that mental check and I saw that this does give you the minimum cost.
Do we have to show that on the final, the second derivative? No,
If
right?
it's, oh, it depends on the question.
Okay.
Yeah, I would do it mentally just to make sure I have the minimal or the maximum at the critical number.
Okay, thank you.
So you can just do a mental check. Like here, this one is concave up, right? If you take the second derivative. So that means your minimum is at the critical number. R equals to this weird looking value.
Okay, thank you.
All right, so please look through it. I worked this final out when we were in spring break, and I try to write as much detail as possible so that you guys can follow through it without me speaking, without me putting my voice on it. To work it out, make sure you go through every topic that we covered in class so that you are ready for every questions, anything that appears on the test. Hopefully you'll be ready for them. So if there are no more questions, you guys are good to go. Have fun, study hard,